All right, today I'm going to talk to you about special right triangles. And there are two special right triangles. One is called the 45, 45, 90, and the other one is called the 30, 60, 90 triangle. And so if you have one of these two special triangles and the Pythagorean theorem is either just too much work or it doesn't work because you don't have two sides, then you can use these special triangles. Because really the Pythagorean theorem will work on the 45, 45, 90 triangle. It will not work on the 30, 60, 90 triangle because you won't have enough information. So the first type of triangle we're going to talk about is the 45, 45. And what that means is you have a right angle and the two acute angles are both 45 degrees. And so essentially this is an isosceles right triangle where the two legs are congruent. So in this diagram here, the two legs are marked x and the hypotenuse is simply x times radical 2. So some students will memorize this figure and then they will use this and use the pattern that's there to help them solve these problems. There's also an equation that you can use, and the equation is that the hypotenuse is equal to the leg times radical 2. And at that point you would just have to plug in what you know and what you're trying to find and solve the equation for x or whatever variable they're choosing. All right, so the legs are going to be congruent and the hypotenuse is simply whatever that leg is times radical 2. And we generally leave our answers in simplified radical form and we don't put them as decimals. So here are some examples. Again, it has to be marked with the 45 degree or the sides have to be marked congruent in order for us to use these rules. So the first one, I know that the leg is 4. So the other leg is also 4 because of the 45 degree marking. So we can conclude that the other angle that's not marked is 45 degrees because we know that the sum of a triangle's angles are 180. So minus 90 minus 45 leaves me with 45. All right. So if I look at my diagram, my legs are congruent and my hypotenuse is simply whatever my leg is times radical 2. So x in this case would be 4 radical 2. So you should be able to look at that very easily and see that pattern and know that the hypotenuse is going to be your leg times radical 2. If not, you can use the equation above and you know that your hypotenuse is x equals your leg is 4 times radical 2 and you get 4 radical 2. All right, number 2. My legs are both 5, so I know this is a 45, 45, 90 triangle because they're congruent. It's an isosceles right triangle. So again, my hypotenuse is equal to my leg of 5 times radical 2. So 5 radical 2 is the hypotenuse. Number 3, they have given us the leg to be 7 radical 2. And now we need to find the hypotenuse. So the hypotenuse is equal to the leg times radical 2. But I need to simplify that. Radical 2, remember, times itself is going to be regular 2. So 7 times 2 is 14. So x on number 3 is 14. All right. If you want to, you can pause the video and try the next two. And even though in the next two, they are giving you the hypotenuse and they're looking for the leg. So I'm not sure, we haven't done one like that yet, so I'm not sure why I would make that a your turn problem. I think I got these out of a textbook and they wanted you to try these. So I'm going to use my equation that says the hypotenuse. So my hypotenuse is 5 radical 2 equals my leg times radical 2. In order to solve this equation, I would divide by radical 2 on both sides. When I do that, my radical 2's cancel. And they also cancel on the other side as well. So that was a nice problem. So my leg is equal to 5. And that looks just like number 2, as a matter of fact, above. So my legs are congruent at 5, and therefore my hypotenuse is leg times radical 2. All right, number 2, I know my hypotenuse is 18, so I'm going to use the equation from above. So hypotenuse equals leg times radical 2. To solve this equation for x, we need to divide by radical 2. And we have learned previously you can't keep a radical in the denominator, so we need to rationalize. So this is where I would multiply the top and the bottom by radical 2. So this gives me 18 radical 2 on top. Radical 2 times radical 2 is 2. And I can reduce 18 over 2. 18 over 2 is 9. And then keep your radical. So number 2's answer is 9 radical 2. So be careful if you're dividing by a radical. You can't leave it on the bottom. You have to rationalize that. And we'll do some more examples with those on the back side of this worksheet. The second type of triangle is the 30, 60, 90 triangle. Again, you have to have one of the angles, either the 30 or the 60 degree, marked. If it's not marked, then you cannot assume it's a 30, 60 degree triangle. And what we have is, we have what's called a short leg. And that is across from the smallest angle. So across from the smallest angle, the 30 degrees, I have what's called the short leg. Okay? And then across from the bigger angle, not the 90 degrees, but the 60 degrees, I have what's called the long leg. And then, of course, across from the 90 degrees, we have what is called the hypotenuse. So we always know across from the 90 degrees is going to be the hypotenuse. So when you know I'm talking about short leg, long leg, or hypotenuse, hopefully you know which side I'm referring to, because that's going to be important knowledge there. With the 30, 60, 90 triangle, you have two equations you can use. You would plug in your information that you know, and you would solve for either x or y. And one of the equations is that your hypotenuse is equal to your short leg times 2. So that one's a really nice, easy one, because if you know your short leg, all you have to do is double it, and that gives you the hypotenuse. The other equation is that your long leg is equal to your short leg times radical 3. So remember, your 45, 45, 90 triangles use radical 2. Your 30, 60, 90 use radical 3. All right, so I can use these two equations, or some students will memorize the layout of the 30, 60, 90 triangle, and they will be able to work their way around that triangle. Because if you know your short leg, you can easily double that to get to your hypotenuse, multiply that number by radical 3 to get your long leg. So short leg is really what you want to know, but they don't always make it that easy for you. All right, let's take a look at some examples. So you need to know who your long leg, short leg, and hypotenuse is. The 10 is the hypotenuse, my x is the short leg, and my y is the long leg. So make sure you know the parts of your 30, 60, 90 triangle. And of course, this is a 30, 60, 90 triangle because of that 60 degrees. It has to be marked. All right, so I can find my short leg by taking half of my hypotenuse, right? Because remember, the formula says your hypotenuse is your short leg times 2. So if that 10 is my hypotenuse, then x would be 5. And then I can go from my short leg to my long leg by multiplying it by radical 3. So y would be 5 radical 3. You can just work your way around your triangle. It's super nice when they give you either the hypotenuse or the short leg. It's when they give you the long leg, you have to do a little bit of thinking and some math. And of course, if you don't see the pattern and you forgot that your hypotenuse is doubled your short leg, you can use the equations above. So you would say that your hypotenuse is equal to your short leg times 2. To solve for x, you would divide by 2. And so we get x to be 5. And you can visually see that that is half of 10. And then you could use the second equation that says your long leg is equal to your short leg, we now know is 5, times radical 3. So either way you look at that, you can use the diagram to help you, or you can use the equations. And I will say, I think on Delta Math, if you try to watch one of their videos that explains these special right triangles, they use proportions. And if you want to understand that, I just think it's a little bit more work involved. But you can definitely set up a proportion using your, I guess this is my template triangle. And instead of x's, you can use 1's there. But I just think that's more work. All right, so number 2, you have to know what you're given. I'm given my short leg. So to go from short leg, I can find my hypotenuse very easily. I just multiply it by 2. So 3 times 2 is 6. And to go from my short leg to my long leg, I simply multiply it by radical 3. Again, you can use the equations above, and you could say that you can plug your stuff in. So you can say your hypotenuse is equal to your short leg times 2. That's how we got 6. Your long leg is equal to your short leg times radical 3. That's how we got 3 radical 3. So either look at the triangles or use the equations. All right, so number 3, this is the ones you have to do a little bit of work when they give you the long leg. So I know that this is my long leg because it's across from the 60 degrees. So I know I've got my long leg. So this is where you might want to use your equations. So my long leg is equal to my short leg times radical 3. And I just got that from those two equations I previously wrote down, and so did you. And so to solve this, I would divide by radical 3 on both sides. Can't have a radical on the bottom, so we rationalize. And I know that 15 times radical 3 is 15 radical 3. Radical 3 times radical 3 is regular 3. And I can reduce the 15 and the 3. 15 divided by 3 is 5. So my answer is 5 radical 3. So kind of work that equation backwards there instead of going right to left, but whatever. All right, so x is 5 radical 3. That's my short leg. Okay. Again, if you need to pause and rewind the video so you can follow that again, you can watch as many times as you need to. Nice thing about videos, I guess. All right, now I have my short leg. So we know we can go from short leg to hypotenuse very easily. Remember, your hypotenuse is double your short leg. So if I take my short leg and I multiply it by 2, so my hypotenuse is equal to my short leg times 2. Oops, and that's supposed to be a 3. Hold on. There we go. So my short leg times radical 2. 5 radical 2 times, or 5 radical 3, I have radical 2 on the brain. 5 radical 3 times 2 is, that's right, 10 radical 3. All right. So again, use your equation, especially if they give you that long leg. If they give you the short leg, it's really easy. You just double it to get the hypotenuse, multiply by radical 3 to get the long leg. All right, so you can pause the video and try these 3 problems, and then unpause the video and see how you did. All right, so number 1, you should have said that 4 is your short leg because it's across from the 30-degree angle. And so because that is my short leg, I know very easily I can double that to get to my hypotenuse. So my hypotenuse is the one across from 90 degrees. So that would be 8. And then I can get to my long leg by multiplying it by radical 3. So my long leg is 4 radical 3. How'd you do? Did you get it right? Fantastic. Number 2, they've given us the hypotenuse. So to go from hypotenuse to short leg, I would take half of 15. Half of 15 is 7.5. To go from my short leg to my long leg, I simply multiply that by radical 3. So y is 7.5 radical 3. Number 3, they've given us the long leg, so this is where I need my equations. Some of you guys can already see the pattern and already had the answer very quickly, but I'm going to say that my long leg is equal to my short leg times radical 3. And what's going to happen to those radical 3's when you divide? They're going to cancel. So x equals 7. Now that I know my short leg, to get to the hypotenuse, what do? You double it. So my hypotenuse is 14. All right, so that is the 30, 60, 90 triangle. Again, use the equations, plug in your sides, and solve for the missing side, if that helps. Some of us can find the pattern and just work our way around our triangle, especially if they give you the hypotenuse or the short leg. If they give you the long leg, that's where I need my equations to help me out a little bit. Don't forget, if you're dividing by radical, you must rationalize if it's still on the bottom, if it doesn't cancel. All right, so let's take a look at the back side of this worksheet. There's some practice